Hi everyone, I'm Qianzhi from Hefei University of Technology. I'm very glad to have such a good opportunity to share our paper with our peers, and also thanks Professor Zhu provides us such an excellent platform. This is our paper's title. Our paper studies fixed cost allocation problems using network DA and game theory. This is the author's information. Our presentation consists of those four parts. First, as we know, fixed cost allocation is a classic problem in management and economics, and also one of hot topics in DA. Previous DA-based allocation methods, many built from the perspective of efficiency, such as efficiency invariance, efficiency maximization, and gradually efficiency improvement. In recent years, network DA research is very hot, since it has some advantages. By opening the black box of the production, it can be helpful to obtain a more accurate performance evaluation result, and can also find the inefficiency source. Recently, how to allocate fixed cost based on network DA has attacked some DA scholars' attentions. For example, Liefen's paper, which has been published in Omega. In this paper, we propose a fixed cost allocation method based on two-stage DA and a non-cooperative game. Some interesting properties are obtained. In section 2, we introduce our allocation method, as shown in figure 1. It is a typical two-stage structure. It can be found that DMUJ consists of two stages. In stage 1, in the first stage, it consumes M inputs to generate Q intermediate output Zj, and in the second stage, the intermediate output Zj is treated as inputs and produce as output Yj. Suppose there is a fixed cost R to be allocated among n DMUs. For DMUJ, the first stage and the second stage are allocated costs are deleted as R1J and R2J. They are treated as new inputs of the stages of the two stages in this paper. Here is the PPS with considering the fixed cost are under the framework of two-stage DA. Then we can further get theorem 1. It at least exists one cost allocation plan satisfying system 4, make all DMU and all stages efficient. But the allocation plan satisfying system 4 usually is not unique. So to obtain an unique and acceptable optimal allocation plan, we propose a fixed cost allocation method based on two-stage DA and a cooperative game. As we know, the final cost allocation plan is directly related to the interest of DMUs. So suppose every DMU is rational and tries to maximize their self-interest. Usually fixed cost is unwelcomed for DMUs. They may escape their burden or responsibility by pay no fixed cost. So we suppose that DMUJ every DMU minimized his allocated cost. In general, the allocation plans proposed by different DMUs are also non-unique. So the game behavior among DMUs is unavoidable. Suppose each DMU proposes his acceptable allocation based on system 4 as the initial allocation. In the first round, DMU-D takes DMU-J's allocation in their into their constraints and then calculate his minimized cost allocation. Therefore, each DMU would compute n times and obtain n minimal allocation result. So we can average the n minimal results of each DMU. In the second round, we use the allocation plan obtained in the first round to replace the initial allocation and repeat the process of the first round. The bargaining process ends when the allocation plan between the T round and the T minus 1 round is within an acceptable error range. And the algorithm is the detailed algorithm is given as follows. There are 3 steps. So we can obtain some interesting properties, such as algorithm is convenient. And also, the optimum allocation plan obtained is a natural equilibrium point. Also, the optimal allocation plan is unique, and the optimal allocation plan is unique no matter which value the initial allocation takes. Yeah. So based on algorithm 1, it can obtain the unique optimal allocation plan for the whole DMUs. Then we need to further allocate the fixed cost for each stage. In this paper, we use the concept of satisfaction fairness to allocate the fixed cost for each stage. This is the definition of the satisfaction, and we suppose we allocate the cost to each stage based on the assumption that the stage for a given DMU have the same satisfaction that is shown as this. Then we can get theorem 6, which is shown as this. The satisfaction of DMU D can be calculated by this simple equation. So in the In section 3, this is a case study. We use a same dataset from the 28. Suppose there are, as shown in table 1, there are 12 DMUs, and those DMUs use 3 inputs to produce 2 intermediate measures in the first stage. Then use the intermediates to produce 2 outputs in the second stage. So by our algorithm 1, we can get figure 2, which shows the convergence, the properties of convergence of our algorithm. And also we can get such a also we can in figure 2 we can obtain the allocation plan for the whole DMU, and then we further allocate the fixed cost to each stage, and we can find that the satisfaction is very fairness, and also we can find that we can find that we can get we can successfully allocate the allocation, the fixed cost to each stage. In table 4, we select 4 initial allocation plans, and we find that the optimal solution is unchanged for different initial allocations. So in section 4, conclusion, in this paper we propose the allocation method, and which has many good properties, and can obtain a Unicode acceptor allocation plan. And also the case study illustrates our paper is valid. So this is the introduction. This is the introduction of our paper. Thank you for your listening. And any questions? Thanks. Also thanks Professor Zhu again.